Welcome to this first in our revision course, going over sheets that my set have done in the last term, starting off with sheet 5 in the course. You can find all the sheets in the OneNote on the attached link, and you can find the answers to the first 4 sheets. They're all on the channel. In due course, the links will all be also in that OneNote sheet, and you'll be able to find the videos in the OneNote sheet. You wouldn't have to go anywhere else. So long as you save that link, you'll get all the updates on there. So our first question we're going to have a go should be a very straightforward differentiating sin and cos bit of revision. I'm just going to give you 2 minutes to have a go at this one. Right, we're going to stop that early because I've got a class with me and they've all finished already. So I'll assume that's plenty of time because it's quite straightforward questions. So if we want to do A, so we're going to do f dashed of x is equal to sine goes to cos. So this will go to 3 cos of x for A. For B, we're going to do f dashed of x. Cos goes to minus sine, so let's go to minus 6 sine of x. And for C, we've got minus 12 cos x, so cos goes to minus sine, so f dashed of x will go to 12 sine x. And part D, f dashed of x, sine goes to cos, and we've got k, so we're going to get k cos of x. So next question. I'll give you a bit longer for this one because it's a bit trickier. And I'm going to give you 5 minutes to look at this one, see how my class goes. If they actually knock this off a lot less, we might stop this early. 1 minute to go. Okay, that's your 5 minutes, and what we're going to do is we'll look at this. Mr. Said says, if b is a constant, cos b must also be a constant. Yes, he is correct. If b is a constant, then cos of that, if you imagine b is 45, cos of 45 never changes, it's a constant. So for part A, the answer is yes. Okay, by writing sine A plus b is equal to sine A cos b plus cos A sine b, and we're going to let b be a constant and a is going to be a variable, so we're going to differentiate with respect to a. So rather than write that all out again, take so long, I'm going to write d dA of that, and I'm going to write d dA of this, and differentiate all of this with respect to a. So if I differentiate this with respect to a, then the cos b is just a constant, so you just treat it like a number. So imagine this is 2 sine a, and it will go to therefore 2 cos a. So this bit just goes to cos a, and that bit just stays the same. So we just get cos a times cos b. And then on this one, so I'm going to rub that out because I made a mistake there. Jumping the gun. Cos a just differentiates to give me minus sine a. Remember, the sine b is just a constant, so imagine that's just going to be 2 cos a, and therefore it will go to minus 2 sine a if you differentiate it. So this sine b doesn't change. So we get a minus, and we get a sine a, and we get a sine b. So d dA of sine a plus b is equal to that. Now we want to explain why d dA of sine a plus b equals cos a plus b. Well, if we want to do d dA of sine a plus b, remember we've got to do a chain rule. We've got a function inside here, a plus b. Now if we do that, if we differentiate d dA of a plus b, and I'm assuming you can all do chain rule in your head, or at least on straightforward ones, d dA of a plus b is equal to 1. So that's what we're going to be timesing by. So we get 1 times by, differentiate the sign, you get cos, and then you just get what was inside using the chain rule. Okay, if you don't know how to do chain rule in your head, then go back and find one of my videos on how to do chain rule in your head and work on that. So this is just equal to cos a plus b. So if this is just equal to cos a plus b, then cos a plus b must equal to this. Right, as our next question, we'll start off, there's a bit of chain rule going on here. Try and see if you can do chain rule in your head on these ones. If you can't, have a go at checking. If you finish them all well within the 5 minutes, check them by doing chain rule the full long way. 1 minute to go. Right, just stopping that a little bit early because the whole of the class with me have finished this question. So let's do d dx of sine 3x. And effectively what we've got to do is we've got to differentiate what's inside here, and that gives us 3. And we differentiate the sine, which gives us cos x. But we want 3x inside here. The function, whatever function's inside remains in the inside function. So that's d dx of sine 3x. Part B, d dx of cos of 2x will be roughly the same. Cos goes to minus sine. Differentiate the 2x to get minus 2 sine 2x. C, d dx of 3 sine 4x plus pi over 6. Differentiate the inside, we're going to get just 4 coming out. The sine will go to cos, and we've got a 3 here. So we've got 4 times 3, so that's 12. Sine goes to cos, and we have everything inside still inside. D, we've got d dx of 2 cos of x squared plus 4x. So differentiate the inside, we get 2x plus 4 times by the 2. Cos goes to minus sine, so we're going to get minus 2x squared. Differentiate that is 2x. So times by 2 is minus 4x. 4x goes to 4 times by 2 gives us another minus 8. Remember, we've got minus times all of that. And then we're going to times that by cos, which goes to minus sine, sorry. I've already taken care of the minus, and we've got everything in the middle here. It's probably better if I'd written it minus 4x plus 8, put the minus outside the brackets. It doesn't really matter. Both of those will be fine. Right, next question. Okay, this is a little bit more problem solving. I need to get some more space on my picture. There we go. I'll give you again 5 minutes to start this. We'll see how the class with me goes, and maybe cut it off early if it's more straightforward than 5 minutes. 1 minute to go. Right, here we go. So we want to find the depth of the water in the harbour throughout the day, maybe modelled by the equation x equals 11 plus 7 sine pi over 6t, where x is the depth of meters and t is the number of hours since midnight. And we're going to show with detailed reasoning. That means you can't just draw your graph. If we did want to, if we did want to draw a graph, there's a copy of the graph I just got from Desmos online. Doesn't do that. There we go. And you can see what the shape of the graph is like. So it helps us understand the problem better if we're struggling with the problem. So there's no reason why you can't draw a graph on your calculator and use it to help you understand the problem if you're struggling with it. So we know that x is equal to 11 plus 7 sine of pi over 6t. And we want to find the maximum and minimum depth of the water. So we want to find this maximum depth of water and we want to find this minimum depth of water. So the maximum is when sine is a max. And the maximum value of sine, sine x, max of this, is it going to be equal to 1? Sine x can never be bigger than 1. If you remember, if you were to draw a sine curve, the maximum value would be 1 and the minimum value would be minus 1. So the maximum value of that is 1. So the maximum in this place is 1. So therefore, x max will equal 11 plus 7, which equals 18. And therefore, x min will be equal to 11 minus 7. Okay, so that gives us 4 meters. Okay, now we want to show a detailed reasoning. Find the speed at which the water level is falling at 4 a.m. So 4 a.m. is around about here on our graph. Okay, and we want to find the rate at which it's falling. So therefore we need to differentiate with respect to time. So we need to find dx by dt of this function here. So the 11 differentiated goes to nothing, and the pi over 6t will differentiate to pi over 6, so we need to times the 7 by pi over 6, so we get 7 pi over 6, and we times that by cos of pi over 6t. So we put t is equal to 4 into this, so that's going to give us 7 over 6 times cos of 4 pi by 6. And 4 pi by 6, if we were to draw a little, sketch of cos, let me just get a bit more space here. Okay, if we want to draw a little sketch of cos, okay, the cos curve does this, and 2/3 pi, okay, is just after here, so it's going to give us a negative value there, and 2/3 of pi, so it's going to be, if we're doing 2/3 of pi, that will give us 0.5, minus 0.5 there, when you do cos of that. So you've got minus 0.5 times 7 over pi over 6, times by minus a half, will give us minus 7 pi over 12 for our answer to this question. Oops, undo that. So I wanted to try and highlight that. There we go. Right, next question. Find all the turning points of the curve y equals 2t to the 4 minus t squared plus 1 and sketch the curve. Again, 5 minutes to do that.
Done the last one.
One minute to go. Right, here we go. So we're going to find the turning points of this curve. So first of all we need to differentiate. So we find dy over dx, and that's equal to 4 times 2 is 8 cubed minus 2t, and we don't need anything else because the 1 goes to 0. So I'm just going to pick a thicker pen. Now, to find the turning points, we make that equal to 0. And I'm going to factorise while I'm at it. I can take out 2t. That leaves me 4t squared minus 1. And hopefully you spotted the difference of 2 squares. So that's 2t, and that's going to be another 2t minus 1 and a 2t plus 1. So therefore, t can equal 0. This could equal 0, so therefore t will equal half. Or t will equal minus a half, our 3 values for t. So therefore, y will equal, and when we put 0 in, we'll get 1 out. When we put half in, we'll get 7/8 out. And when we put minus a half in, we'll also get 7/8 out. So if we want to draw a quick sketch of our graph, it's going to be symmetrical about 1. We know it's a quartic, and because we know it's symmetrical about, sorry, not 1, by x equals 0 because of where the turning points were. We had a turning point, remember, at minus a half, and we had a turning point at plus a half. And that's y value is 1, and the y values, these should be level, I haven't drawn that very well, should be 7/8. And that is our answer. Y equals 2t to the 4 minus t squared plus 1. We should know that a quartic is either going to be U-shaped or W-shaped, or if it's the other way up, M-shaped or an N-shaped graph. Right, next question. Find the area closed by the line y equals x plus 1 and the curve y equals x squared minus 2x plus 1. Just drawn them on here to help you and also to help me when I do my answer. So here you go, 5 minutes. Actually, you should take that less. I'm going to switch that to 3 minutes. Right, that might have been a bit time pressured. It's good to do some questions under time pressure. So we want to find the area enclosed by the line y equals x plus 1 and y equals x squared minus 2x. So this is y equals x plus 1, and this is y equals x squared minus 2x plus 1. And what we can see is the area we want is below the x plus 1 and above the x squared minus 2x plus 1. So if we were to find the area underneath the x plus 1 and then subtract from that the area under x squared minus 2x plus 1, because integrating finds the area between the curve and the x-axis, then we would get our purple area here. So I'm going to do it that way. There's two ways to do this question, and I'll do the slightly longer way so you appreciate how you can subtract areas, because when you're doing ones which cross the axes, you've got to be quite careful and break questions down properly in there. And this is a good idea to actually always practice doing this rather than trying to take shortcuts. And I'll show you the shortcut method as well while we're doing it. So if we want to find the area between, we can see it crosses at 3 and 0. And you probably, actually, if we're doing this properly, we ought to find where they cross. So let's just show where they cross. Take this away from both sides. We get x squared minus 3x. And the ones cancel. Factorize, you get x and x minus 3. So we can see it crosses at 0 and it crosses at 3, which you wouldn't have had in the graph. So we've got this trapezium, it's crossing at 0 and 3. We've got the line x, y equals x plus 1, so that's going to be 4, and that's going to be 1 at that point. So this area, that's going to be 4, that's going to be 1, is going to be equal to the distance between them, which is 3, times by the average of these two, so that's 4 plus 1, which is 5 over 2. So that gives you 2.5 times 3, which gives you 15 over 2 for that area. Now we can find the area between here, the red curve, by integrating between 0 and 3, x squared minus 2x plus 1 dx. So let's do that. We get x cubed over 3 minus x squared plus x between 0 and 3. And we could put the 3 into this, so we get 27 divided by 3 is 9, minus 9 plus 3 gives me 3. Put 0 into this, I'm going to take away 0, I get 3. So that will give me 3 for that area. So therefore, the area required is equal to 15 over 2 minus 3. And that comes out as 9 over 2, or 4.5. Now another way to do this is to recognize that it's just going to be the integral of x plus 1 minus x squared minus 2x plus 1 dx, and just do that one integral. And obviously you can simplify this, so you get minus x squared, and you're going to get plus 3x, and the ones are going to cancel. And you could just integrate this and get that answer. Once my students got it the wrong way around, got a minus answer, and recognized that the area should be positive. Do be careful which way around you take these and make sure you get them the right way round. So next question. If I can click on it. It is here. Sorry, I forgot to put the link in. So nice, easy one. This should only take, I think, about a minute. So let's see if you can knock it off in a minute. Right, this question. So we want to calculate the arc length, perimeter, and area of a sector. Actually, it probably was a bit much to do in 1 minute. Sorry, I didn't realise there's 3 things. So we want to calculate the arc length. We've got a sector here. We know this angle is 2 pi over 3, and the radius is equal to 6. So the arc length is just equal to r theta. So we're just going to get 6 times 2 pi over 3. So that gives us 4 pi. And we want to find the perimeter. So the perimeter is going to give us, add on 2 lots of the radius. So we get 6 plus 4 pi. So that just gives us 12 plus 4 pi. And then for the area, it's a half r squared theta for the formula. Do learn all your formulae off by heart. So we've got a half times 36 times by theta, 2 pi over 3. So we can see that 3 into 36 is 12, so it's just going to be equal to 12 pi. So it probably was doable in 1 minute. Right, that's all from sheet 5. We'll be doing sheet 6 tomorrow at the same time. See you then.